Skyscrapers, like temples and palaces, are considered a representation of a city's economic strength. In this new era of architectural ingenuity, there is a hint of showmanship among developers to build the tallest and most spectacular structure. In Dubai, one of the 7 emirates that make up the United Arab Emirates, one of the world's tallest buildings is reaching up over 800 meters into the clouds.
It must take a lot of people to plan something like that.
Yes, a team made up of industrial, mechanical, and chemical engineers, a city planner, and interior design experts ensure that all components of the building's specifications are met. In an attempt to bring a new image to the Middle East, planners are creating space and living for 10 million inhabitants. Along a stretch of 7 kilometers, 140 skyscrapers are being built, each one taller than 300 meters. The center of attention in this extravagant plan is a massive skyscraper, the Burj Dubai.
Is it the tallest in the world?
Yes, it stands 800 meters tall. And surrounding it is a whole new district with offices, parks, an artificial lake, and 320,000 luxury apartments. There's even an old town quarter embodying traditional Islamic architecture. The goal is to transform Dubai into a service and tourism-oriented city. Crowned the tallest building with the highest roof, antenna, and inhabited space in the world, the Burj Dubai is the outstanding landmark of the new district. A symbol of architectural excellence. The crews working on the towering structure are pioneers in the construction industry. A 3,000-strong labor force from Pakistan, India, and Bangladesh work around the clock in 10-hour shifts. The high temperatures, along with up to 90% humidity, are tough even for those used to working in such harsh conditions. The entire downtown project surrounding the Burj employs some 25,000 workers on the biggest construction site in the world. A quarter of the world's cranes are used. 2/3 of the Burj Dubai is constructed from reinforced concrete, and never before has so much steel been used on such a small architectural footprint. The steel elements, powerful as they are sealed completely by concrete to guarantee that no air or water comes in contact, and the steel must be protected by concrete in case of fire.
The high temperatures must have made it difficult.
Yes, the daytime heat left them no choice but to pour cement at night. In the daytime, imported massive cranes hauled up tons of materials.
We have 3 big construction cranes up here. There's 1, 2, and the one behind is 3. These are the biggest construction cranes in the world. One actually came off Petronas Towers in Malaysia. These cranes are called self-climbing cranes that actually climbs up inside the building. These cranes are supported off the walls downstairs at 2 locations with big beams. So what they do is they put a 3rd level of beam here, so it's supported on 3 beams. Then the bottom beam gets loosened, so it's supported on the top 2. And then the crane jacks itself up. It has a big hydraulic jack in the bottom of the crane that goes up like this. And it catches and goes up again, 1, 2, 1, 2, like this. So it makes, in 24 hours, we can jump this crane about 20 meters.
In the end, 1 crane was left to mount the 200-meter spire that crowns the Burj Dubai. For a building of this magnitude, extensive maintenance planning was necessary for managing power, climatization, and water. Every material distributed throughout the building was pumped or driven upwards against the force of gravity. A multitude of pumps, pipes, generators, and distributors service the entire building. Every 20th level is reserved for these logistics. These floors have much higher ceilings in order to house all of the equipment. For developers, the biggest concern is climatization. A common problem in skyscrapers is that some rooms can be flooded by too much sunlight, causing them to heat up. The cost and energy used to cool a building of this magnitude is huge, as the hot desert sun can produce temperatures of up to 50 degrees Celsius, or over 120 degrees Fahrenheit.
Do they try to make them energy efficient?
Yes, Ken Yang, a London-based architect who designs bioclimatic buildings, is having major success in Asia. His focus is on the sustainable or green skyscraper.
Bioclimatic basically means designing with the climate of the place to lead to a low energy building. And so essentially the objective is low energy, but has to respond to the climate of the location. Once you apply the principles to the skyscraper built form, then the built form has to respond to the climate, to the sun, to the wind, to the rain, to the seasons of the year.
Using natural resources, Ken Yang has developed groundbreaking techniques in an attempt to make skyscraper life more eco-friendly. Using rainwater, he creates falls of fine water mist inside the building. A vertical landscape comprises several levels of extensive gardens. And for natural cooling, the wind is harnessed to replace conventional air conditioning systems whenever possible. Openings on the facade edges allow wind into the building, where it's directed through atriums, light yards, and balconies.
They're making a constant supply of fresh air.
Yes, and an individual concept is drafted for each project's unique local climate conditions. They work with recyclable materials that combine maximum strength and durability. These architects are developing a design to work with nature in the form of a bionomic skyscraper. It will incorporate a feature known as an adaptive facade. Climate-adaptive facades differ from conventional ones in that they are able to adjust their characteristics to the changing environment, therefore maintaining a comfortable indoor temperature, lighting level, and air quality without excess use of energy. In nature, skin is an example of a multitasking organ. It protects against moisture while allowing air to permeate. The design goal is to create a breathing building that can adapt to the environment like a living being. By cladding shape memory alloys, the facets can change their form and flexibility through electro-impulses as needed to maintain environmental and structural stability.
Will this help keep skyscrapers from swaying in the wind?
Yes, an adaptable structural frame may counterbalance the sway effect on the top floors if the lower areas are able to actively alter their form. At over 800 meters tall, there is some expected sway on the Burj Dubai. Chief Structural Engineer Angus McFarlane planned for winds that have the potential to exert 2.5 tons of pressure per square meter on the building.
Wind is still a problem because it's a predominant load, but the building, as you've seen out there, has facets. This disrupts the wind force. What it does, there's a thing called vortex shedding, and little vortices come off the building, and they come off at a frequency, and this can accentuate the wind loading. Whereas in this building, because of the faceted, stepped shape of it, it disrupts the vortex shedding and reduces the wind load to a minimum.
Aside from the wind, the engineers also focused their attention on the downward compressive stress on the supporting walls. They used a new kind of special concrete that can withstand 500,000 tons.
Well, the concrete is very difficult on a project like this. The whole whole structure is reinforced concrete, and it's very high strength concrete. It's actually 100 newtons per millimeter squared, which even in Europe and America is difficult to achieve. So here in the Emirates, this project and also the airport project, which is now ongoing, they were the first projects to have specified 100 Newton concrete. Very strong concrete. And to achieve that, you need very careful design of the concrete mix. You have to have good materials. You have to have very good cement, fresh cement, aggregates from the mountains here. And you have to have special chemicals like retarders and superplasticizers to make the whole thing work.
In future construction, elevations won't be cast, rolled, or forged as much. They will be woven. Researchers are developing a material which is lightweight, yet as durable and flexible as steel. Again, nature is the model for this synthetic plant stock. Looking for an ingenious combination of strength and flexibility, this weaving machine integrates hundreds of meters of synthetic fibers, which will take the place of steel. This is a three-point bending test to determine the limits of the material. The stock has a tensile strength limit of 15 kilonewtons, or 1.5 tons. A steel-reinforced structure would have already failed. Every material has its limits. However, this new material has a greater ductility at its breaking point in that it does not suddenly split or tear.
Do they test how the weather will affect it?
Yes, in this specially designed chamber, they will simulate the effects of how heat, cold, and intense UV light would affect the material over a 30-year period. The Burj Dubai will include 3,000 residential apartments, office space, and several hotels featuring the Armani, the flagship for a new international chain.
What skyscrapers are going up in other parts of the world?
In London, skyscrapers are mostly confined to Canary Wharf to preserve the city's historical skyline. Now, Sir Norman Foster's 180-meter Gherkin rises in grandiose fashion. Other new projects, such as Bishopsgate Tower and the Shard London Bridge, will change the London skyline. Kuwait, another country building a whole city, the City of Silk, will showcase a tower reaching 1,001 meters high. This skyscraper will cost $100 billion to construct, and the estimated completion date of the city is 2030. This skyscraper, which is named 1001 Nights after the book of collected Arabian stories, is to be a symbol of peaceful coexistence between all cultures, as it will have 3 spires including a mosque, a synagogue, and a cathedral. This sprawling City of Silk will be home to 750,000 people. 100,000 will be provided space for living, working, and recreation in the 1001 Nights. Here is a basic comparison of the heights of some well-known skyscrapers around the world. As the Burj Dubai is nearly 2 times taller than the Empire State Building, 1001 Nights dwarfs them all. Between planning, raising funds, and construction, there is extensive work to be done. As crews work diligently around the clock, somewhere else, the next team is planning a taller, more complex skyscraper. Persian Gulf countries are attempting to diversify their petroleum-centric economy to multi-use and multicultural-driven centers. They are shaping a new identity. In the future, architects and engineers will work together to advance the stability, efficiency, and technology of skyscraper construction.
Skyscraper is such a 20th century name. We need a new name for a new century. And so we suggest Star Catchers is a little bit better. You know, there's this fabulous quotation out of John Young's Night Thoughts that just is one of the most endearing quotes that I've ever heard. What he said was, "Too low they build who build beneath the stars." And I think today when we're talking about buildings of a kilometer in height, we're reaching for the stars, not just the sky. And something that for the 21st century that represents the desire to uplift the human spirit higher than it's ever been done before. That's what these buildings are symbols of.